Okay, so here's part 4. So let's draw a truth table for the conditional statement if P then Q. Okay, again we have two statements PQ, right? So we have four possibilities. For half of them P is true, right? For half of them P is false. We focus on the situations, when P is true. When P is true, we have two options for Q is either true or false. And then when we have false values for P, we have two options for Q is either true or false. So we have true, 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 false, false, true, false, false. Okay, now if P, then Q. Okay, guys, that's very, very important and interesting rule. If your start antecedent is true and your consequent is true, if P then Q is a true value. If your start is true and your consequent is false, if P then Q is false. If your start, your antecedent is false, you don't even need to look at your consequent. We consider the conditional statement true. Well, what does it mean? Okay, so guys, if your start antecedent is false, you don't need to look at your Q. Conditional statement is considered true. Okay, well, I'm gonna provide an example for you. Okay, let's say I tell you that if I win the lottery, then I will travel around the world. Okay, I win the lottery is P and I travel around the world is Q. I tell you, if I win the lottery, then I will travel around the world. Okay, let's say I win the lottery, that's true. And I travel around the world, that's true. Then if P then Q is true, because that's what I told you. If I win the lottery, then I travel around the world. I win the lottery, that's true. And I travel around the world, that's true. Then if P then Q is true. Nothing wrong with that. Guys, if I win the lottery, it's true, but I don't travel around the world, Q is false, then I lied to you if P then Q is false, right? So, whenever your start is true antecedent and your consequent is false, conditional is false, right? I win the lottery, but I don't travel around the world. In that case, if P then Q is false. Okay, so I tell you, if I win the lottery, then I travel around the world. Guys, if I don't win the lottery, but I travel around the world, there is nothing wrong with that. So if P then Q is true. And if I don't win the lottery and I don't travel around the world, right? There's nothing wrong with that if P then Q is true. Okay, so if you have a conditional statement, the only way that your conditional statement is false, that's when your antecedent is true and your consequent is false. It's like I win the lottery and then I don't travel around the world. In that case, if P then Q is false. So that's the only way that your conditional statement is false. That's when your antecedent is true and your consequent is false. Otherwise, you have true values for a conditional statement. That's a very important rule, right? Okay, here we go. So, let's go back to the example that we had. We had an argument and we wanted to see whether or not this argument is valid. So first line, it tells you if you invest in Widget Incorporated, then you get rich. Second line, you didn't invest in Widget Incorporated, therefore that's your conclusion. You didn't get rich. Okay, we said that we have to follow 4 steps, right? Step 1, break the arguments into simple several statements and call them P, Q, R, S, right? Okay, that's what we did. I see 2 simple statements in this argument. One is that you invest in Widget Incorporated, I call that P, and the other one you get rich. Okay, so P and Q. So, step 2, change the whole argument into symbols. Okay, so look at first line. if you invest in Widget Incorporated, then you get rich. That's a conditional statement. It's if P, then Q. Look at the second one. You didn't invest in Widget Incorporated. You invest in Widget Incorporated is P. You didn't invest is not P. Negation. Therefore, guys, you see the conclusion. You draw a line. Here we go. Now we have the conclusion. Here is the sign for the conclusion. You didn't get rich. You get rich is Q. You didn't get rich is not Q. Okay? Don't forget to label whatever you have above the line. Okay? These are your premises. Whatever you have below the line, that is your conclusion. Okay? Here we go. So, now we can move to step 3. Make a truth table. And then step 4, make sense of the truth table. Okay, guys, when you make a truth table, okay, well, we have two statements, P, Q. Okay, first of all, don't forget to label. Whatever you have above the line, they're your premises. Whatever you have below the line, that's your conclusion. You have two statements, P and Q, so you have 4 possibilities, right? So, you always start from P and Q, okay? And then you build actually the premises and conclusion in your truth table, okay? Just like here, guys. I have PQ, okay? PQ, right? So I start with P and Q, okay? So we have 2 statements. We have 4 possibilities. For half of them, P is Q. For half of them, P is false. When P is true, you have 2 options for Q. Q is either true or false. And when P is false, we have 2 options for Q is either true or false. Now that you have built up for P and Q, now you need to make the premises and conclusion. Guys, look at the first premise, okay? Premise 1 is if P, then Q. So you need to make that if P, then Q. So here we go. That's premise 1. Here we go. If P, then Q. We said that for the conditional, if your start is true, your conclusion is true, well, conditional statement is true. Look at the second row. Your start is true, antecedent, right? Your consequent is false, your conditional is false. Well, we said if your start is false, you don't even need to look at your consequent, right? Your antecedent is false, conditional statement is considered to be true. Okay, so we build up the first premise. Now I'm going to make the second premise. The second premise is not P. Well, here we go. Premise 2. Okay, well, is not P. That's the negation of P. Whatever value you have for P, not P has the opposite value. So P is true, not P is false. P is true, not P is false. P is false, not P is true. P is false, not P is true. So you have built up premise 1 and premise 2. Now we can make the conclusion. So here we go. The conclusion is not Q. Okay, here we go. Guys, don't forget to label them, okay? Conclusion. So not Q, that's the negation of Q. Whatever you have for Q, not Q has the opposite value, okay? So Q is true, not Q is false. Q is false, not Q is true. So Q is true, not Q is false, and Q is false, not Q is true. Okay, now we want to make sense of the truth table. That's step 4. Okay, what we do, okay, guys, we need to make actually a column, okay, in the truth table that shows premise 1 and premise 2. Okay, here we go. So here it is, premise 1 and conjunction, premise 2. Okay, premise 1 and premise 2. So that's column 3 and column 4. You use and conjunction rule between these 2 columns, okay? Between this column and this column, you're going to use and, okay? So For and, we said both the statements must be true. Okay, so look at the first row. Okay, both the statements must be true. One is false, so we get false. Both the statements must be true. Both are false, right? We get false. Look at the third row. Both the statements must be true. Both are true, we get true. Look at the fourth one. Both the statements must be true for and. Okay, both are true, we get true. Okay, we made premise 1 and premise 2. Okay, so then we make if premise 1 and premise 2, then conclusion. So we have a conditional if premise 1 and premise 2. Okay, well, if premise 1 and premise 2, then conclusion. Okay, so if this row, that's your antecedent, then conclusion. Okay, so here's your antecedent, right? So here's your conclusion. So here's your star. Guys, your antecedent is false. You don't even need to look at your consequent, right? The conditional statement is considered to be true. Now, look at the third row. Your antecedent is true. Your consequent is false. So conditional is false. Your start antecedent is true. Your conclusion is true. Well, it's true. Well, now we can actually make sense of the truth table. If all the values in this column, the column of premise 1, if premise 1 and premise 2, then conclusion, if all the values are true, that we call that tautology, then the argument is valid. Okay, as you see, all the values are not true. We have a false value here, right? So we do not have tautology, so the argument is not valid. Okay, so guys, there is another way to make sense of the truth table, the step 4. Okay, I'm gonna explain that too. Well, let's say we have this argument. If you invest in Widget Incorporated, then you get rich. You didn't invest in Widget Incorporated, therefore you didn't get rich. Well, step 1, we choose simplest statements. We call them P and Q. P, you invest in Widget Incorporated. Q, you get rich. Step 2, we change the whole statement, the whole argument into actually symbols. And as you see, whatever you have above the line, they're your actually premises, right? Whatever you have below the line, that is your conclusion. Okay, so step 3, you make a truth table. Well, you have two statements, P and Q. You start from P and Q, then you make all the premises and conclusion. Okay, so we have two statements, P, Q. We have 4 possibilities. For half of them, P is true. For half of them, P is false. When P is true, Q is either true or false. When P is false, Q is either true or false. Then we make the premises. One premise is if P then Q. Here we go. If P then Q, here it is, premise 1. Okay, so your start is P, true. Your conclusion, your consequent, Q is true. So conditional is true. Your antecedent, your start point is true. Your consequent is false. So conditional is false, right? So your start is false. Your antecedent is false. You don't even need to look at your consequent. Your conditional statement is considered to be true. Okay, that's the rule for the conditional statement, right? Okay, that's premise 1. Then you make the other premise. The other premise is not P. That's easy. Here you go. That is premise 2. We have P, not P, has the opposite logical value. P is true, not P is false. P is true, not P is false. P is false, not P is true. P is false, not P is true. Okay, now that you have made all the premises, now you can make the conclusion. Here we go, conclusion. Okay, conclusion is not Q. That's easy. We have Q, not Q has the opposite values. Q is true, not Q is false. Q is false, not Q is true. Q is true, not Q is false, and Q is false, not Q is true. Now you have built up all the premises and conclusion. Now you can stop here, guys, in this way. Okay? Now you need to make sense of your truth table. Okay? What do I do? Well, I only focus on the premises and conclusion, just this part of the table. Okay? Guys, I go row by row. Okay? If I find any row for which all premises are true, but conclusion is false, then I have an invalid argument. If I cannot find such a row, then I have a valid argument. Okay, so I go row by row. All premises true. Okay, I'm looking for a row that all premises are true and conclusion is false. If I find that row, I have an invalid argument. If I cannot find such a row, then I have a valid argument. Okay, so I go row by row. Okay, I look at the first row. Okay, so all premises must be true. No, premise 1 is true, premise 2 is false. So that's out, useless. Look at the second row. All premises true. Okay, no, both premises are false. Okay, out. Look at the third one. Okay, guys, I'm looking for a row that all premises are true, just like here. Premise 1 is true, premise 2 is true, okay? And conclusion is false. Here we go. I found it. I found the row I was looking for. If you can find at least one row for which all premises are true and conclusion is false, then you have an invalid argument. Otherwise, if you cannot find such a row, you have a valid argument. Okay, I found it. That's it. I have an invalid argument. I was able to find at least one row for which all premises are true and conclusion is false. So I have an invalid argument. Here we go. Invalid argument. Okay, so guys, it's up to you. If you are given, an argument, you can actually follow the previous rule. You make premise 1 and premise 2. If premise 1 and premise 2, then conclusion. If all the values are true, then you have it to be called a tautology. You have a valid argument. If all the values are not true, just like we had a false value, then you have an invalid argument. If you don't like that way, you can follow this one. Well, you make a truth table. You make premises and conclusion. When you make premises and conclusion, you can stop there. Then you can go row by row. If you find at least one row for which all premises are true and conclusion is false, then you have an invalid argument. If you are not able to find such a row, then you have a valid argument. Here we go. Okay. If there is any row for which all premises are true and the conclusion is false, then the argument is invalid. Okay. So, we have an example here. Well, that's from your textbook. It says find out whether or not the argument is valid. If it's cold, my motorcycle will not start. My motorcycle started, therefore it's not cold. Okay, what I'm gonna do, I'm gonna follow all the steps. So step 1, I choose PQ. I break the whole argument into simple statements, okay? So I see two simple statements. One is it is cold, and the other one, my motorcycle starts, okay? So I call them P and Q. So P, it is cold, and Q, my motorcycle starts. Okay, PQ. Guys, in your textbook it says that make sure that do not use negated values for P and Q. For example, Q is my motorcycle started. I don't say my motorcycle did not start. So it's better to use positive, not negated statements when we choose PQ, okay? So, well, that's step 1. Step 2, change the whole argument into symbols. Okay, look at the first line. Okay, we have two premises, line 1, line 2, and then we have a conclusion, right? Okay, look at first line. It's conditional. If it is cold, my motorcycle will not start. Okay, that's a conditional. So if it's cold is P. If P, then my motorcycle will not start. My motorcycle starts is Q. My motorcycle will not start is not Q. Look at the second line, number 2. My motorcycle started. My motorcycle starts is Q. Okay. Therefore, guys, we have a line. That's therefore. That's the conclusion. Sign. It is not cold. It's cold is P. It's not cold is not P. That's step 2. Now step 3. I make a truth table. Okay. So I can make a truth table right here. Okay. I start from P and Q. We have two statements. We have 4 possibilities. For half of them, P is true. For half of them, P is false. When P is true, Q is either true or false. And when P is false, Q is either true or false. Here we go. So now I make the premises. Guys, look at premise 1. I have if P, then not Q. Okay, I have conditional statement. My antecedent is P. My consequent is not Q. Because my consequent is not Q, so I'm going to make not Q first, and then I make if P, then not Q. Okay, so not Q, that's easy. That's the negation of Q. Whatever I have for Q, I make it the opposite. Q is true, not Q is false. Q is false, not Q is true. Q is true, then not Q is false. And Q is false, not Q is true. Here we go. So now that I have not Q, I can make the first premise. If P, then not Q. Okay, so here we go. That is premise 1. Okay, if P, then not Q. If P, here you go. That's your antecedent, not Q is your consequence. So we have conditional statement between column 1 and column 3. So your start is true, your antecedent, your consequent is false. So conditional is false. Your start is true, consequent is true. You get a true value. Your start, your antecedent is false. You don't need to even look at your consequent. The conditional statement is true. Now, premise 2 is Q. Okay, guys, you can just label, Q as your second premise, or you can rewrite it. So I rewrite it Q. Here we go. Premise 2. So we have true, false, true, false. I just rewrite it, okay? Now I have premise 1, I have premise 2. I can make the conclusion. Conclusion is not P. Here we go, not P. Here is the conclusion. Well, we have P, not P has the opposite value. P is true, true, false, false. So here we have false, false, true, true. Exactly the opposite, right? Okay, now we have all the premises and conclusion. That's step 3. Now we can move to step 4 to make sense of the truth table. Well, I'm gonna go with the second methodology. I stop here and I go row by row. Okay, I only focus on the premises and conclusion. I go row by row. If I find any row for which all premises are true and the conclusion is false, then I have an invalid argument. If I cannot find such a row, then I have a valid argument. Okay, so all premises true, conclusion false. So I go row by row. Okay, first one, all premises must be true. No, one is false, out. Okay, look at the second one. All premises must be true. No, one is false, out. Okay, guys, look at the third one. All premises are true. I look at the conclusion. No, that's true. I'm looking for a case that all premises are true, conclusion is false, right? So third column, no, conclusion is true, out. Well, I look at the last one. All premises must be true. No, one is false. Okay, that's out. What happened? I was not able, okay, I'm going to write it down. I was not able to find a row with true premises and a false conclusion. Well, therefore, the argument is valid. If I find a row for which all premises are true, conclusion is false, I have an invalid argument. I wasn't able to find such a row. If I cannot find a row with true premises and a false conclusion, then the argument is valid, just like here. I have a valid argument. Okay, so here we go. I pick P and Q. P it's cold, Q my motorcycle will start. Then step 2, I change the whole argument into actually symbols. So I actually, as you see, label premises and conclusion. Okay, then I draw a truth table, right? And then I went row by row, and I couldn't find any row for which all premises are true and conclusion is false. Guys, the only case that all premises were true, conclusion was true. I'm not looking for that one, right? I want all premises to be true and conclusion to be false. I couldn't find that row, so I have a valid argument. Here we go. Okay. So we can actually follow the first methodology. Well, I have premises, I have the conclusion, I build up the truth table, I make the premises and conclusion, but then I keep going. I make premise 1 and premise 2, and then if premise 1 and 2, then conclusion. If all the values in the final column all are true, then we have a tautology. We call that a tautology, okay? Then we have a valid argument. So a tautology happened here. We have a valid argument, okay? So as you see, we have the same answers, right? Well, the truth table for the biconditional statement, that's really easy, okay? We have PQ, P if and only if Q, okay? PQ, true statements for possibilities. For half of them, P is true. For half of them, P is false. When P is true, Q is either true or false. When P is false, Q is either true or false. So we have true, 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 false, false, true, false, false. P if and only if Q. Well, if P and Q, guys, both have the same values, for example, both are true, biconditional is true. If both are false, both have the same logical value, then biconditional is true. Otherwise, that's false. Okay, so a biconditional is true only when the component statements have the same truth value. If both are true, biconditional is true. If both are false, biconditional is false. Both are false, biconditional is true. So if they have actually the same values, biconditional is true. So both are true, biconditional is true. Both are false, biconditional is true, right? So when P and Q are exactly the same, they have the same logical values, biconditional is true. Otherwise, it's false. Okay? So, let's look at, a situation that we have 3 statements. So far, we have talked about, just having 1 statement or 2 statements, P and Q, right? Let's say we have P, Q, and R, okay? And you want to make a truth table, okay? For example, let's say we have a complicated, line, a complicated premise. We have if P, then not Q and R, just like here. Guys, if I want to draw a truth table, first of all, I have 3 statements, P, Q, R, okay? If you have 1 statement, just like P, we have 2 possibilities. It's either true or false. If you have 2 statements, P and Q, we have 4 possibilities, right? If you have 3 statements, you have 8 possibilities, guys. Okay, we have PQR. It's actually, to be honest, to the power of n. N is the number of statements that we have. If n is equal to 1, right? When n is 1, 2 to 1 is 2. If you have one statement, you have two possibilities. If you have two statements, P and Q, 2 to the second power is 4. You have 4 possibilities. When n is 3, you have 3 statements, P, Q, and R. 2 to the third power is 8. Then you have 8 possibilities. Again, just like before, you have 8 possibilities. For half of them, P is true, 1, 2, 3, 4. For half of them, P is false, 1, 2, 3, 4. Okay? When P is only true, just guys focus on the first part. When P is true, well, for half of the possibilities, Q is true. For half of them, Q is false. Okay, well, when Q is only true, you have two options for R. It's either true or false. And when Q is false, you have two options for R. It's either true or false. Now let's focus on the second part. When P is only false, we have 4 options for Q. For half of them, Q is true. For half of them, Q is false. When Q is only true, you have two options for R. It's either true or false. And when Q is only false, you have two options for R. It's either true or false. So as you see, we have 8 possibilities. True, true, true. True, true, false, true, false, true, true, false, 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 true, true, false, true, false, 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 true, and false, false, false. Okay. Well, we start P, Q, and R. Guys, I want to make if P, then not Q and R. P is antecedent, that's easy, we have it. But consequent is not Q and R, okay? So I'm going to make not Q first. I'm going to add a column for not Q. That's easy. Whatever you have for Q, not Q is the opposite one, right? So now that I have not Q, okay, I can make not Q and R, okay? So not Q and R, it's like you have conjunction, not Q and R, between the column of R and column of not Q. So for conjunction, for and, both the statements must be true to have a true value. Okay, so not Q and R, both must be true. One is false, you get false. Both must be true, both are false, you get false. Both must be true. Guys, here, both are true, you get true. Okay, both must be true. One is false, you get false. Both must be true. One is false, you get false. Both must be true. Okay, both are false, you get false. Both must be true. Okay, guys, both are true here, you get true. Both must be true. One of them is false, you get a false value. Okay, now you have not Q and R. What do we want to make? We want to make if P, then not Q and R. Okay, so if P, then not Q and R. Okay, P is here. Here is your antecedent, right? Not Q and R is your consequent, right? So here is your start. Here is your actually consequent. Guys, your start is true, consequent is false, conditional is false. Your start is true, consequent is false, your conditional is false. Your start is true, consequent is true, then conditional is true. Your start is true, consequent is false, you have a false value. Guys, when your start, your antecedent is false, you don't even need to look at your consequent. Your conditional statement is considered to be true. So we made it, right? Okay, so just to have a break, I'm gonna give you this example and I want you to change these statements into symbols, okay? So global warming will increase, we call that G. We will develop alternative energy sources, I call that A. And C represents Congress will pass new energy legislation. We have 4 statements. I want you to change them into symbols. So I give you around 1 minute, okay? Go ahead. Okay. So, first statement. Global warming will increase or Congress will not pass new energy legislation. Okay. Global warming will increase. Global warming will increase is G, or disjunction is the sign for or Congress will not pass new energy legislation. Congress will pass new energy legislation is C, so will not pass is not C, negation. Here we go. Second one, we will not develop alternative energy sources. Okay, we will develop alternative energy sources is A. It says we will not develop is not A. Okay, and conjunction and global warming will increase. Global warming will increase. G. Now look at third one. If, okay guys, that's conditional. If global warming doesn't increase, global warming increases G. If global warming does not increase, if not G, then, okay guys, this is like comma. Whatever comes after is the group. Congress will not pass new energy legislation. Okay, Congress will pass is C. Says Congress will not pass is not C. And we will not develop alternative energy sources. We will develop is A. We will not develop is not A. Here we go. So if not G, then not C and not A. Okay. Last one. If, again, we have condition. If Congress will not pass new energy legislation, Congress will pass is C. If Congress will not pass, if not C, then, guys, this is like comma. Whatever comes after and before is the group. Okay. Then what happens? Global warming will increase. Global warming will increase is G. Or, okay, disjunction. Or we will develop alternative energy sources. We will develop alternative energy sources is A. Is that right? Well, let's see. Here's the answers. Well, here we go. Just check and see if the answers are right. Okay. So, if the following argument valid, if the tire is flat, then I will have to remove it and take it to the gas station. Tire is not flat, therefore I will not remove it and will not take it to the gas station. Guys, step 1, break it into simple statements. Well, I see 3 simple statements. One is tire is flat, the other one I have to remove the tire, and the third one I take it to the gas station. So I call them P, Q, R. Okay, so I break it. P, tire is flat. Q, I have to remove the tire. And R, I take the tire to the gas station. Okay, so that's step 1. Step 2, write the argument in symbolic form. Okay, change the whole argument into symbols. Well, just read it. If the tire is flat, if P, then what happens? I have to remove it and take it to the gas station. If P, then Q and R, right? Well, tire is not flat. Tire is flat is P. Tire is not flat is not P. Therefore, now I have the conclusion. So I draw a line. Here we go. The conclusion is I will not remove it. I remove it is Q. I will not remove it is not Q. And here we go. And I will not take it to the gas station. I take it to the gas station is R. I do not take it to the gas station is not R. So whatever I have above the line are my premises. Below the line is the conclusion. That's step 2. Now, I can build up a truth table. Okay, I make a truth table. I make all the premises and conclusion. Okay, as you see, we have PQR. We have three statements. Okay, so we have PQR. We have three statements. So we have 8 possibilities. For half of them, P is true. For half of them, P is false. When P is true, just focus on the first part. P is true. For half of the possibilities, Q is true. For half of them, Q is false. When Q is true, R is either true or false. When Q is only false, R is either true or false. We do the same for the second part. When P is false. When P is false, we have 4 possibilities for Q. For half of them, Q is true. For half of them, Q is false. When Q is true, R is either true or false. When Q is false, R is either true or false. Now, guys, I want to make the premises, okay? So, one premise is if P then Q and R, the other one is not P. Okay, look at the first premise, okay? If P then Q and R. P is the antecedent, Q and R is the consequence. So I'm gonna make Q and R first, okay? Q and R. So that's the consequence. Okay, Q and R is like we have and between Q and R, right? For and, both of them must be true, okay? Otherwise, it's false. So both must be true. Look at the first row. Both are true, we get true. Both must be true. One is false, we get false. Both must be true, guys. Look at the third one. Okay, third row. Okay, one is false, we get false. Look at the next one. Both must be true. Both are false, we get false. Look at the next one. Both must be true. Both are true, we get true. Look at the next one. Both must be true. One is false, we get false. Both must be true. One is false, we get false. Both must be true. Both are false, we get false value. Now that we have Q and R, we can make the first premise. If P, then Q and R. Okay, here we go. Here is premise 1. Okay, if P, that's your antecedent. Okay, then Q and R. Q and R is your consequent. Okay, here we go. If P, then Q and R. Okay, your start antecedent is true. Consequent is true. We get a true value. Your start is true. Consequent is false. We get a false value. Your start is true. Consequent false. Conditional is false. Antecedent is true. Consequent is false. Conditional is false. Okay, when your start, your antecedent is false, you don't even need to look at the consequent. The conditional statement is considered to be true. Okay, we made premise 1. Okay, now we want to make premise 2. Premise 2 is not P. Okay, that's easy. We have P, not P is actually the opposite value. So we made the premises. That's premise 1. This is premise 2. Okay, we made the premises. Now I want to make the conclusion. Guys, conclusion is not Q and not R. So I'm going to make not Q and not R first, and then I use conjunction between them. Okay, not Q, that's easy. That's the opposite of Q. Not R is easy. Whatever you have for R, you make it the opposite, then it's not R. Then we can make the conclusion. Okay, conclusion. We can actually use the and rule between not Q and not R. Okay, for and, both must be true to have a true value. Both are false, you get false. Both must be true. One is false, you get false. Both must be true. One is false, you get false. Okay, both are true, you get a true value. Both are false, you get false. Both must be true. One is false, you get false. Both must be true. One is false, you get false. Okay, here, last row. Both are true, you get a true value. Okay, now we only focus on the premises and conclusion. We go row by row. If you find at least one row for which all premises are true and the conclusion is false, then we have an invalid argument. If we cannot find such a row, then we have a valid argument. Okay, so I want all premises to be true. Okay, go row by row. First row, one is false, out. I want both to be true. Okay, second row, false, out. Third one, out. Fourth, out. Okay, look at the fifth row. Okay, all premises are true. I look at the conclusion. Okay, that's false. That's exactly what I was looking for, guys, right? Okay, I was able to find a row for which all premises are true and conclusion is false. So I have an invalid argument. Okay, there is a row for which all premises, here you go, are true and the conclusion is false, right? So the argument is invalid. If I find at least one row, I'm good, right? I found it. I don't look at the other ones, okay? That's it. So I have an invalid argument. Okay, there is a similar question, very, very similar to what we answered right now. I leave it to you. So I want you to answer that question. If there is any problem, then let me know. Okay, here we go. I'm gonna stop here and give you a break, okay? Here we go.